Hello, class 9. Today we'll learn numericals based on second law of motion. So, question number 1 from the book itself. A body of mass 5 kg is moving with a velocity 2 meters per second. Calculate its linear momentum. So, here let's look at the solution. Linear momentum we know is equal to mass into velocity. So simply we'll put the value of the mass, which is equal to 5 kg, and the velocity, which is given as 2 meter per second, and we'll multiply them. So multiplying 5 kg with 2 meters per second, you will get 10 kg meter per second, which is the required linear momentum of the given body. So this is the required answer. Next is question number 3, which says a force of 15 Newton acts on a body of mass 2 kg. Find the acceleration produced. So here the force of 15 Newton is there and the body mass is 2 kg. We need to find the acceleration. And this, the force, the mass and acceleration, the relation is given by force equals mass into acceleration by this formula. So force is 15 newtons, mass is 2 kg, and will represent acceleration as A. So 15 Newton is equal to 2 kg into A, where we can find the value of A by taking 2 kg on the other side. That will be 15 divided by 2. So when you divide 15 by 2, you will get 7.5. That is the value of acceleration, which is 7.5 meter per second squared. Remember, in case of acceleration, you will have meter per second squared. So there will be the power 2 in the unit of acceleration. Next is question number 6. A force of 10 Newton acts on a body of mass 2 kg for 3 seconds initially at rest. Calculate the velocity acquired by the body and change in momentum of the body. So here the force is, the force of 10 Newton acts on a body which is initially at rest, and its body mass is 2 kg, and the force is applied for 3 seconds. So we will write down the data from the question. That is, force is given as 10 Newton, the mass is equal to 2 kg, and the time period for which the force acts on the body is 3 seconds. So now we have to find the velocity acquired by the body. So let's look at question number part 1 of this question. So here force is equal to mass into acceleration. So from the given data, we'll find out the acceleration first. So force is 10 Newton, mass is 2 kg, and acceleration is A. So just like the previous question, we'll find out A, which is equal to 10 Newton divided by 2 kg. When you are doing the calculation, you don't need to write the units. At the end, you can write down the units. So 10 divided by 2 is 5. So acceleration is equal to 5 meter per second squared. So now, since the acceleration is 5 meter per second squared and initially the body was at rest, that means the initial velocity was 0. Now the acceleration is 5 meters per second squared, and the time on which the force is applied is 3 seconds. So we can use the relation V is equal to U plus AT, where V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time. So we have to find the velocity acquired, that means the final velocity V, which will be equal to initial velocity is 0 plus acceleration is 5, okay, and time is 3 seconds. So 5 and 3, when you multiply, you will get 15 meter per second. That is the velocity acquired by the body, and that is the answer for part 1. Next is part 2. We have to find the change in momentum of the body. Now, change in momentum means we'll find out the initial velocity, initial momentum, and we'll find out the final momentum, and we'll find the difference, that will be the change in momentum. So, initially, the momentum of the body was m into v. That is the formula. Momentum is equal to m into v, where m is the mass and v is the initial velocity. And initial velocity in this case was 0. So 2 kg the mass multiplies with 0 velocity, so gives the momentum 0. So initial momentum is 0, and when it is 0 you don't need to write the units. Then final momentum is again mv, where v is the final velocity that we have got from here. Okay, now m is 2 kg and the velocity is 15 meter per second. So when you multiply this, the final momentum becomes equal to 30 kg meter per second. So final momentum is this, and the initial momentum is 0. So the change in the momentum of the body is equal to the final momentum minus the initial momentum, that is 30 minus 0, which is equal to 30 kg meter per second. So this is the required answer, that is the change in momentum of the body. Lastly, we have question number 8. Here in the figure, which shows the velocity time graph of a particle of mass 100 grams moving in a straight line, we have to calculate the force acting on the particle. So here is the graph, okay, which shows the velocity time relation of the particle of mass 100 grams. So let's look at the solution. We have got the body, the particle whose mass is 100 gram. Now 100 grams, since it is in gram CGS system, and here the velocity is in meter per second, as we can see out here. This means we have to do our calculation in SI unit. So the mass 100 grams, let's convert it into SI unit, that is in kg, which will be equal to 0.1 kg. Now from the graph, the velocity is 20 meter per second, as the dotted line shows over here. When the velocity is 20 meters per second, it corresponds with 5 seconds time. That means in the time 5 seconds, the particle acquires the velocity of 20 meter per second. So the time is 5 seconds. So here we will use the relation v is equal to u plus at. From here we can see that initially it started from 0. That means initial velocity was 0. So we'll write the final velocity is 20, as we can see from here. Okay, 0 is the initial velocity. We can see it started from 0. That means the initial velocity was 0. Acceleration a we don't know, we need to find, and the time is 5. Okay, that is the 5 seconds from the graph we can make out. So 20 is equal to 0 plus a5, that is 20 is equal to 5a, or a is equal to 5 goes down as a denominator. So 20 by 5 is equal to 4 meter per second squared. So this is the acceleration that the particle has acquired. So 4 meter per second square is the acceleration of the body of the particle. Now we have to find the force which is acting on that particle. So since the force can be given by F is equal to m into a, m into a means mass multiplied with acceleration, where mass is 0.1 kg. Okay, 0.1 kg into 4 meter per second squared, and that gives us 0.4 Newton. Since we are finding out, we have to find the force, its unit is Newton. So 0.4 Newton is the required answer.